everyone, and welcome to This Explainer. Today, we're going on a massive globe-spanning journey into the very nuts and bolts of our modern technological world. We are unpacking the incredibly complex and fiercely competitive electrical and electronic equipment industry. But we're doing it through a very specific lens, the rigorous sustainability standards that track exactly how these companies operate, innovate, and ultimately survive. Just picture it for a second. Imagine a high-tech, cinematic matrix of global shipping ports working around the clock. Think fully automated factory assembly lines and engineers analyzing digital blueprints that are being beamed across international supply chains in absolute milliseconds. This is a deeply mature industry. The companies building our power generation equipment, our smart building controls, and our automation systems, they aren't just local players. They operate on a massive global scale, generating a huge portion of their revenues far, far beyond their home countries.
Okay, let's dive into this taxonomy. We start up at the macro level with the resource transformation sector, and then we navigate precisely down into the electrical and electronic equipment industry. And that gives us our specific classification code for today, RTA. Now, the rules guiding how these companies measure their impact, they are serious business. These standards are rigorously maintained by the International Sustainability Standards Board, right under the stewardship of the IFRS Foundation. And the specific version we're exploring today is effective for all reporting entities for annual periods beginning on or after January 1, 2025. Basically, the bar for corporate transparency has officially been raised.
So, here's our roadmap for This Explainer. We're going to cover the global RTE landscape, power and cleanup, safe products, sourcing materials, and finally, global ethics.
Let's jump right into Section 1, Power and Cleanup, focusing on energy and waste. Look, manufacturing complex electronics isn't a purely clean process. It generates some serious byproducts. We're talking about heavy metals and wastewater treatment sludge that are governed by incredibly strict transport, treatment, and disposal regulations. The stakes are super high here. Effective treatment and recycling don't just protect the environment, they literally mitigate massive long-term remediation liabilities and regulatory penalties for the company down the line. What's truly fascinating here is the level of precision required. The SASB standards don't just ask companies to try to use less energy or recycle more. No way. They demand hard, quantifiable data. Companies have to track total energy consumed in gigajoules, breaking down exactly what percentage comes from the grid and what percentage is renewable. For hazardous waste, they must report the absolute weight generated in metric tons, alongside the precise percentage that is actually recycled, reused, or reclaimed. And the protocols backing up that data? Incredibly strict. You can't just guess your fuel consumption. You have to use gross calorific values or higher feeding values to calculate it. Claiming renewable energy isn't just sticking a single solar panel on the factory roof either. It requires specific, verified structures like Green Energy Certified Utility programs or retaining renewable energy certificates. Plus, if a company operates in an area with weak local laws, the standards step in and suggest using the UNEP Basel Convention definitions for what actually constitutes hazardous waste. Honestly, there are no loopholes here. Moving right along to Section 2. Safe products and lifecycle management. Product safety and lifecycle management is essentially a double-edged sword. On one side, it's all about preventing catastrophic failures, think electrical fires, that lead to devastating litigation, involuntary recalls, and massive brand damage. But on the flip side, it's about optimizing the environmental footprint during the product's actual use phase. Companies that design highly energy-efficient products don't just do it for good PR. They actually achieve a much stronger competitive positioning and capture way more market share. This creates a really interesting contrast. On one side, you have your safety risk indicators, like how many recalls were issued, what were the actual monetary losses from legal proceedings. Then, on the other side, you've got your life cycle opportunity indicators. What percentage of products are certified to energy efficiency standards, and how successfully is the company phasing out potentially harmful substances under the IEC 62474 standard? Let's see how this builds into an entirely new revenue stream. Companies are actually required to disclose their total revenue generated from products specifically designed for renewable energy and energy efficiency. We aren't just talking about making a laptop slightly lighter. We're talking about smart grid technologies, intelligent building controls, and complex systems like turbine controllers and switchgears. These are fundamentally required to integrate renewable energy into our established infrastructure. Next up is Section 3, Sourcing Materials and Supply Chain Risks.
So the crucial point here is understanding exactly what makes a material critical. By definition, in these standards, a critical material is one that is both absolutely essential to the use of the product and subject to a high risk of supply restriction. Because these materials are often sourced from only a handful of countries, immense geopolitical uncertainty and fierce global demand create a highly fragile and incredibly risky supply chain. Just listen to some of these required materials. I mean, it sounds like science fiction. Platinum group metals like iridium and palladium, cobalt, tungsten, and gallium. Rare earth elements like yttrium and scandium, along with an entire suite of lanthanides like neodymium and europium. These aren't just random rocks. They are the highly specific, incredibly complex ingredients at the absolute base of this global industry. Without them, production literally grinds to a halt.
Because the risk is so astronomically high, entities are required to openly discuss and disclose exactly how they manage these physical limits on availability. They have to detail their mitigation strategies. Are they actively diversifying their global suppliers? Are they stockpiling materials? Are they funding research to develop substitutes? Or maybe heavily investing in new recycling technologies to recover these critical materials from end-of-life products? Ultimately, investors need to know that these companies can weather a sudden supply chain shock.
And finally, we arrive at Section 4, Global Ethics and Corporate Governance.
Think about it. When a company headquartered in a region with strict laws operates heavily in a region with very weak legal enforcement, they are highly vulnerable. Unethical practices like bribery, corruption, or anti-competitive behavior might seem like a quick local shortcut, but they can trigger devastating regulatory scrutiny, massive legal costs, and profound reputational damage on a global scale.
And this brilliantly illustrates the elegance of the SASB standard framework. It looks at the whole picture. On one hand, it asks for qualitative discussion. What due diligence procedures and policies do you actually have in place? Are you following the OECD anti-corruption guidelines or the Transparency International business principles? But then, it immediately grounds that qualitative policy in hard quantitative reality. Companies must disclose exact monetary losses resulting from legal proceedings related to bribery, corruption, price fixing, or patent misuse. It essentially proves whether those internal policies actually work out there in the real world. The sheer scale of what these electrical and electronic equipment entities must track and manage is honestly staggering. From the specific heating value of their factory fuel, to the amount of hazardous waste they recycle, to the rare earth metals inside their components, all the way up to international anti-corruption laws. It's a massive undertaking. So I'll leave you with this. How will the next smart device, lighting fixture, or building system you interact with measure up against this completely invisible yet massively influential global matrix of safety, efficiency, and ethics? Thank you so much for joining me on this explainer, and keep asking the big questions.